So VLAN trunking protocol. Right, these are all my switches. What happened in this one? These are all my switches. I connected them. Okay. These are all my switches. Twelve, and it went in the middle. It went and again started at 90, 91, 92, 93, 94, 95, 96, 97, 98. Okay, these many switches I have. How many? 98 switches. Okay. Again Messi came late. Again Messi came late. Messi, network admin at Cisco. He was late again to the office. Manager again, he was angry with him. Now he gave a task. Configure. What? Configure 98 switches. 98 switches with 50 VLANs each. How many? 50 VLANs each. Every switch must have, yeah, VLAN number 1 to VLAN number 50. You configure. Okay, this is the task. Again Messi is thinking. Now Messi became smart like Usman again. Okay. VTP. Okay. So what he did is he made this switch VLAN number 1. Sorry, switch number 1. Okay. He made it server. He made it VTP server. VLAN, so switch 1 is now VTP server. He made all these switches as clients. Right? He gave on all these switches, he gave a domain name. He gave a domain name. All these switches. What is a domain name? Manager's task. Okay, manager's task. He gave the same domain name to all the switches. Now what he did is he configured VLAN number 1 to VLAN number 50 only on this switch. Only on the VLAN number, only on the switch number 1, he configured switches. He configured VLANs from 1 to 50. Okay. Even before that, he made all these links as trunk using DTP. He used DTP and made all these switches as trunk. Within half an hour, all the switches are in network. All the links between all the switches are trunks. He made VTP server 1, that is switch 1. He gave the domain name, manages task. All these he did in 1 hour. And he configured VLAN number 1 to 50 in 1 more hour. Only on server 1. Now, remaining all the switches till 98, from 2 to 98, the VLANs are created. VLANs are created. Manager came back after 3 years. Manager came back after 3 years to check whether Messi is doing the configuration or not. But what happened? Messi went to game station. Where did he go? He went to game station. In their office they had game station. He went to game station, started playing FIFA. What is the latest version of FIFA? Huh? What is the latest version of FIFA? No. I played 14, so FIFA 14. He's playing FIFA 14. Manager came here. He asked, "What are you doing?" I told him, "Sir, I'm playing. My work is finished. I'm playing." He was confused. How did you finish this? Messi took the manager here. Check whatever the switch you wanted. Check whatever the switch you wanted. VLANs will be created. What actually baseline of the story is? First thing is Messi used VTP. In order to use VTP, we must have trunk between the switches. Yes. First requirement. Second requirement, he gave the same domain name on all the switches. In order to relay the VLAN information from one switch to other switch, all the switch must be belong to same domain. Okay. So he gave the same domain name, that is manager's task. Manager's task. Okay. He created with one server and one client. So one server and all the clients. So VTP works on server and client mode.
Whatever the computation he did on server.
Yes, he did a configuration on the server. All the clients got the VLANs. All the switches got the configuration. All the clients got the configuration. So now you got the baseline how VTP works. VTP works on server and client mode. In order to VTP make work, we need trunks between all the switches, and all the switches must be under the same domain name. Right? Actually, if you're using VTP, if you configure VLANs on one server, all the clients will be updated with that VLANs. The VLAN information is relayed or advertised using VTP. This is why we use VTP. Doing this, what happened? The overhead of Messi has gone down. Instead of going to every switch and configuring, what he did? He just sat on one switch, right? He just sat on one switch and configured 50 VLANs. Remaining all the switches got the configuration. The same thing. VTP, how it got? VTP has relayed that information from server to all the clients. The prerequisite of VTP is trunk must be there and domain name must be same. That is VTP. Right? So VLAN trunking protocol used to advertise the VLAN attributes, right? Whatever the VLANs are configured, VLAN information, everything will be advertised. Minimizes the administrative overhead, right? Message overhead has been reduced. This will Discuss within 2 minutes. And trunk should form and domain name must match on both the sides. Then only VLAN information can be accepted by the client. Okay, they must be under the same domain. If not, it will not accept the information. First thing. Second thing is it will break the trunk. Whatever the trunk is between you and me. You are telling that you are the server belong to manager's task. But I am configured as I belong to the domain task of manager. There's a difference. There's a difference between manager's task and task of manager. I will break the trunk, and you will also break the trunk.
Because it's not shared.
Yes, they are not in the same domain. That is why we call it as VLAN trunking protocol. Trunking is also dependent on VLANs. This VTP, so it is called VLAN trunking protocol. Okay. So what is this revision number? A simple thing. So actually VTP, how VTP works is, this is my server and this is my client. Okay. This is my server, this is my client. First, whenever an update has come, whenever the admin has configured a VLAN, whatever the thing he did, we have revision number. We have revision number. By default, at the starting point, by default it is 0. Now, whatever the configuration you do regarding VLANs, you created one VLAN, it will increment by 1. I created VLAN 1, sorry, I created VLAN 2, revision number becomes 1. Now I added a name, I configured a name for VLAN number 2, it will be incremented. The value will go for 2. Whatever the configuration you do, for every one configuration, the value will be incremented by 1. Right? This is the first thing. Second thing is, now my CR number has increased on server. Right? I created one VLAN.
Yeah.
CR number has increased, revision number has increased. Yeah. It will tell the client that my CR number has increased.
So that will update.
Yes. Now you are the client, I am server. My CR number is 1, revision number is 1. I will send you my CR number is 1. You will ask me what happened. Mine is 0, yours is 1. What is the change? Tell me the change. You will request me. Request. I will send you the information that a VLAN is configured. Configure this VLAN on you. This is the process of VTP. Okay. Now I send you the message. Okay. That something is changed. Right. Now I send you the, within 5 minutes I send you another thing, another update. Right. What will you think? You will think that just before 5 minutes before I got the message that there is an update, and now I got the same message again that there is an update. How should I know that there is definitely a change?
By telling the change.
By telling the revision number. By revision number, uses revision number to determine the recent updates. Okay, for this purpose revision number is used. If you send me one revision number, I will compare that revision number with mine. If it is same, I will reject it.
You will reject it?
Because revision number is same.
Okay.
I'll think that everything is what on the same line. We are on the same line.
Yeah.
Okay.
Yeah.
If I'll get a revision number greater than mine, I will send you a request. What happened? So this is the usage of revision number in the VTP. Okay. Recent updates are tracked using revision number. And higher revision number takes preference and default is 0. Default starts with 0. And if I get a higher revision number, ultimately I will go for the revision number and I'll ask the server what has happened. Right?